Okay, so we're gonna use this formula. You can use either one, but this one is more general. Okay, so we just gotta force it to look like this. Currently, it doesn't really look like it, so we gotta do some weird algebra. So what we can do is rewrite that x and the 4. Now, I don't have a 4 here, right?
Yeah.
So what we could do, because we need a u squared minus that squared. So what we can do is 4 squared. That's good. That's fine. No, this seems okay. But then that number 5 there would just be your A. So yeah, okay. I thought I had to do more work, but I don't. Sorry about that. So our U is the X and our A is the 4.
Right.
So our answer will be, once you do the integral, our answer will be 1 over 4 arc secant of x over 4 plus c.
I have a question here.
Mm-hmm.
So when we say integral of x square root of x square, it should be square root of x square all square. Like the x power 4 should be x square all square, not x all square. There is the square here, yes.
I write it down wrong?
Yes, x power 4.
It should be,
We write it down as x power 2. It will be x power 2 power 2.
Oh, yes.
And the u should be x square then.
Yeah, you're right. Hold on a second. Yeah, I knew that looked too easy. Okay, so then b squared. There we go. Which means this needs to be squared. Interesting. So then what we could do maybe we could do a u sub first. Let's see if that works. So if we let u equal x squared, du will not be there. Let's see what happens. Okay. X is on the bottom though. If I introduce an x, there's power 4. Hold on. Yeah, I don't think that's gonna work.
I suggest if this one will never come in the in the exam, we can ignore it altogether. Don't give you hard time because I have enough hard time with this one. I can give you another problem. I will ignore this. I don't think that you can do that for us.
It's okay. It's just a weird one.
I was going to say, could you do x to the fourth and then 2 to the fourth? Would that do anything?
We have to have an x squared out here in order to use the arc, because it is going to be arcsecant. We just have to rig the question. So in order to do so, yeah, I think the sub will work. We just got to get clever. So yeah, this is a weird one. I'm not going to lie to you. I mean, the questions on the test aren't usually that kind of difficulty, but that's why they're for homework. These are the fun ones, right? You can obsess over it for hours. So what we can do.
I pulled the I separated it. I made it two separate angles.
You separate it?
Yeah, that's what I did first. Then I looked my U substitution for each one, and then I went back. That's what I did. I don't know if it was the way I got it.
Well, let's see. So if I let u be that, du is not there. But I do need an x squared down here, right?
Mhm.
So I could
Divided by 2, right?
divided by 2. Something's missing.
Isn't it U square equals x squared in parentheses squared, the whole thing, and then you find the U from that, and that'll give you your U square.
What we could do, because I need a x squared down here, right? That's what I need. That's what I need there. But I also need a 2x. So if I introduce a 2x, then all this will cancel back to here, right? These are equal.
Yes.
So now I can do the sub, which will get me to here. So this will become du over u square root u squared minus 4 squared.
How you get the x square? How you converted the x to x power 2 in the previous step?
Because I put an x up here, so this will cancel one of them, right?
Ah, okay, got you.
And I needed a 2x on top to replace with du. So I introduced 2x, which also helped me create an x squared at the same time, which allowed me to replace du, u, and this u.
Right.
So yeah, that was a weird one. So now we're good. So this would be just a secant, right?
Yeah.
Secant of u over 4, absolute value. Arcsecant, actually. So that'll be arcsecant of u over 4 plus c, which is really, the formula says 1 over a is in front. So let me show another step for you. So the half's already there, right? But the integral comes with a 1 over a, and our a is 4. So it's actually 1 over 4 right there. So at the end, when everything's said and done, you'll have 1/8 arc secant of x squared over 4 plus c. There we go. Sorry, that took me a little bit. That was
Thank you so much. I apologize about this one.
yeah, that was a hard one. I see why you were stuck, because that was a weird trick, right? Like, how do I force that to be square? Because we know these has to match, right? The inside.
Yes.
So I had to try to force it. So the u sub helped simplify it, but then I couldn't u sub it. So I had to kind of rig the whole thing. Had to
Do you
force
prefer
it.
to take another problem from someone else? Because I have one or two more, just maybe one more. Do it
Okay.
now or after you take another problem from another
Yeah,
one.
anyway, we can do it real quick. That's fine. Do one more.
Okay. The one more integral.
Another great weird ass one.
Yes. 7 over
7 over
25 plus
25 plus
open bracket 5 minus x all square. Like close the bracket and then all square. dx. Thank you.
Okay. This looks like a arctan, right? So let u equal 5 minus x, du equals negative dx, right? So negative du would be, well, I need a 7, but I could pull it out. It's not a big deal. dx. So I'm going to pull out the 7 so I don't have to worry about it. The top part will be replaced with negative du. So I'm going to pull out that negative over here. Is that cool if I skip that step? 5 squared plus u squared. So at that point, we will have arctan. I forget the arctan formula though. Pretty much done now.
The arctan formula is going to be arctan u over a plus c.
Arctan u over a plus c. Nothing in front.
No, it does not have anything in front.
Okay, excellent. So it'll be negative 7 arc tangent of u over a, which is u over 5, which will be negative 7 arc 10 of 5 minus x over 5.
Okay, I have a question here, maybe because I'm overthinking.
Mhm.
The u equal 5 minus x. Can you show me how you integrate it to get the negative dx? I know it's dumb question, but I lost.
The derivative of 5 is 0, right?
Yes.
Derivative of negative x is going to be dx, negative dx.
Oh, we add 1 to the x, like how to, yeah, how you do it now? I'm sorry.
So we take derivative of u with respect to x. You would take the derivative of this whole thing, right? So du dx would equal negative 1. So multiply over negative dx. That's what we've been doing, but we've been skipping this step because we've been doing this for a while.
Yes, I know.
We
I
jumped
get
to here.
disconnected. Yeah, I got disconnected.
So this is why. Does that make more sense? Or no?
Yes.
Okay.
Yes, thank you.
Yeah, that's fine.
The last one, and this should be an easy one. Integral
Mm-hmm.
of 1 over x power 8 over 9. X power 8 over 9.
Like this?
No. 8 over 9 in the power. 8 over power 8 over 9.
Oh, interesting. Okay.
The homework was very interesting, actually.
X to the 8 over 9.
8 over 9. Open bracket.
Okay.
2 plus x. And this x is power 1 over 9 by itself. 1 over 9. Close bracket dx. That's it. Yeah.
Okay. Maybe write that a little bit prettier. Okay. All right.
Is that 1/9 or 1
Yeah.
over?
1/9 power. So it looks like we have probably an arctan kind of deal, but the powers are weird. Now, if we multiply it in, you get a 2 here, 2x 8, 9. This would be a whole, so that'd be 1. There's no power outside, right?
No.
Just like this. Okay. Oh, I see it. Okay. Let's see. So let u be 2 plus x to the 1/9. Du will be 1/9 x to the negative 8/9 du, right? Or dx rather. There is no 1/9 there. So multiply by 9 and we get this. But this is a negative power, so you can move it to the bottom. That would be x 8/9, which we have, right? We have the dx on top over here. We have the x 8/9 down there. So this can be subbed now into just 9 du over u. So this is just 9 ln u. 9 ln of 2 plus x to the 1/9 plus c.
Okay, this one is right. This one, the previous one, the one that you solved above. I don't have the paper where I solved it all the steps, but it ended up to be -7/5, not -7 arctan. The previous one, I just looked to the homework, so it's
Oh, there's a 5 here.
over
Yeah, I
5.
think.
Yes.
Yeah, so there must be an a over here. The arctan probably has a 1 over a then in the formula.
Yes.
I must have
Yes.
forgotten it.
Yes.
Gotcha. Okay. Then yeah, this should be good.
Thank you so much. That's it.
Does it make sense?
Yes.
Okay. So I'm sure that's a good review for everybody anyway. Okay.
The reason we bought the 5, I'm sorry, going back to the other question we said.
Mhm.
-7/5, that's because we had a 5.
Yeah, the a should be down here, I think. So it's u over a. Then there should be
We take the
an
inverse.
a right there too.
Okay.
Can you push the paper up a little bit so I can
Yeah.
look in the bottom?
Mhm.
Thank you.
Okay. You guys see this? This is when you open the review, it's gonna look like this. Similar to how your exam's gonna look. So you're given a question, and you just start showing all your steps on the paper. Don't worry about this. I mean, maybe it can help you, but if your answer doesn't look exactly like this, who cares? If you show your work and it works out, just stop, right? Because sometimes the answers, I don't know if you've noticed, right? Like the answers in the book or the answers in the homework, they go and have these perfect algebra answers. They're prettier, but sometimes your work might not be as pretty, but it's still correct because you stop at a certain point. You don't keep trying to polish the algebra. So sometimes these answers might not be what you get. So be careful. Don't let them mess with your head. If your work is good, that's what matters. But look at this question 1. Is this a question you want to do, or does it look doable? Can you integrate this?
If this one may come to the exam, I want to see this one, question number 1 for sure.
This is on the review test. I'm gonna it's open right now. You can take it whenever just to practice.
Okay, got you.
So I want to do some of them for you. Okay, I don't know if I have time for all of them, so let's go through it. Does this one seem hard? It's going to be, they're telling you what to do with the U sub, right? And then you do the du and start your integration.
Oh, okay.
Because I already told you, so I'm hoping it's not difficult. This is just a U sub question. There's no no inverse trig, no ln. It's just a cosine type. This guy is a basic U sub, very easy question. I'm gonna skip this one for sure, but you guys okay on one? We can do it if you want to.
Let's just work it out. That sounds good.
Okay, not a big deal. Let's try it out. Yeah. Okay. So let's review question one. So the integral of square root x cosine squared of x to the 3 halves minus 6 dx. And they're telling you to use this up. So if they tell you, that means it shouldn't be too hard. So du will be, bring down the 3 halves, subtract 1 from this power, that would be 1/2 minus 6. Oops, no, 0, it's gone, sorry. There should be a dx there. Oh man, it's weird. Okay, so we have the root, right? We do not have a 3 halves, so multiply both sides by the opposite, the reciprocal, so 2/3 du will cancel that fraction, leaving you with x 1/2 dx, right? So x 1/2 dx is right here, right? U is right there. We should be good. So we will have cosine squared of u times 2/3 du. So let's just get rid of that 2/3, put it outside. 2/3, it's gone. So now we just have to integrate this guy. What is the integral of cosine squared? If you're unsure how to deal with cosine squared, you can always use the power reducing formulas, right? From trig. I believe that cosine squared x is equal to cosine 2x plus 1 over 2. Let me double check though. I feel like I missed something there. Yeah. No, actually, that's right. It's just usually written the other way. That's why it bothers me. There's nothing wrong with that. I just prefer to write it this way. 1 plus cosine 2x over 2. Okay. So you can replace it using your trig identity from way back when. That'll be 1 plus cosine 2x over 2 dx, right? So now it's doable. 2/3. So I can separate this fraction. Right? So 1/2 cosine 2x over 2. This is an easy integral. This one's kind of easy. Oops, I made a mistake. This should all be u, not dx. We replaced x, remember? Okay. There we go. All right, so this integral would be no big deal. That'll be 1/3 u. This guy, we got to do a little extra work. So if I multiply the 2 and the 2/3, that'll be 1/3. So now we just got to deal with this guy. So let, I don't know, w, I guess, equal to 2u. dw is equal to 2 du. So dw over 2 is equal to du. So let's keep on going here. So we will have 1/3 u going along for the ride plus this 2 integral 1/3 integral of cosine w dw over 2. So I'm kind of doing a sub within a sub, which is a little weird. Pull out the 1/2, that'll be 1/6 integral of cosine w. The integral of cosine will be sine, right? So replace u and replace w, and we're good. So this will be 1/3 x to the 3/2 minus 6 plus 1/6 sine of 2u. Bring back that u. That will be x 3/2 minus 6 plus 1/6 sine of 2. Let's put a bracket now because it looks weird. 2 times x 3/2 minus 6. Okay. I guess that wasn't as easy as I thought it was, but whatever. Is there any steps that were confusing? As far as you can multiply the 2 if you want, but it's good enough, I think. So it looks like it's going to be,
Oh, so we multiply the 2, it doesn't really matter.
no, I mean, you can multiply it in.
Make the 2.
Looks like they have, looks like it's going to be C, I think. C matches up with what I have. Okay. Right, that's this guy here. So sometimes you have to do more than one sub. Okay. This one, so we're gonna skip that. You guys have any questions on number 3?
Yeah, let's work that one out. I was having problems with these.
Integral of dx over x ln x6. Should correct it spelling. Oh well. Okay. So this has to be a u sub. Let u equal ln x. So du would be 1 over x dx, which is right here. So then let me check something. Hold on a minute. Yeah, it should be fine. Okay, so then this should be du over u to the,
To the power 6.
yeah. But I think there's something wrong here. Because I guess I need to make sure something. Does this mean this? Or does it mean this? Hold on a second.
The computer tells you ln x and then the brackets and then power 6.
Oh, the middle one?
Yeah, that's the way I was getting it wrong on the homework because I thought it was the other way, like ln x of power of 6, but it's
Okay.
ln x power of 6.
So if it's this way, then the sub should be good. The only thing is, so then we can choose this. The derivative would be bring down that power. No, that would be uglier. Would not work. Oh, I see. Okay. I think I see it. Let's see. Let's just try to do it. Let's assume this is right. So integration of this guy would be u to the -5 over -5 plus c, right? Add 1, divided by the same thing, which would be -1/5 ln of x to the -5 plus c. Yeah, just to match up any of the questions. So I'm trying to think that was not the correct idea. Yeah, I think it's gonna be like this. Yeah, because this answer doesn't make sense. Because if the power's there, then I can bring it down. So then I would have, yeah, that makes sense. So then that would be 6 over x. There is no 6, so we would have 6 du equal to 1 over x dx. So then the sub would be 6 du over u. That would become 6 ln of u plus c, which is really 6 ln of x to the 6. Okay.
So as an explanation, so we let u equal ln x power 6, and then the du equal what? 6 over x?
Oops, that should be 1 6 right there. Hold on a second. What did you say? I'm sorry.
I'm saying how we get from the ln, from the u, the du, how we did the derivative.
Oh, so from this step to this step?
Let u equal ln x6 power x power
Mhm.
x power 6, and du equal 6 over x dx on the right. The first step of the, yeah, in here. How we get from this step to the next one.
Oh, okay. So do you remember the properties of logarithms where you can bring the 6 down?
Yes.
So if I bring it downward, take a derivative. The derivative of ln is just 1 over x. So I just put the 6.
Become 6 over x.
times
Okay, got you.
1 over
Okay.
x. So that gets us to here. Then I have to divide the 6 out because there is no 6. So I get 1x dx, which is already there. So then I can sub the top part in the bottom. So you'll get du over 6. So this is really 1 6. There we go. Sorry, I don't know if I went a little fast there. Is there any steps that make sense? Because I was kind of thinking it through there a bit. Do you understand the sub and how I got to here?
Yes.
Okay. So it's ln 1 6 ln of 1 6 times ln of ln x to the 6. So it looks like the d is going to be d. Okay. The next one is pretty. You should share screen again. This one's just a u sub. I'm gonna skip that guy. It's easy. This guy is another u sub, but it's a little more complicated. Oh, it's cotangent. That's why. So you use the cotangent formula after you do a u sub. Do you guys want to do number 5, or do you see it?
Yeah, let's do number 5.
Okay. So that was, what number was that last one? That was 3. Okay. So e to the t times cotangent of e to the t minus 7 dt. So let u equal to e to the t minus 7. Du will be e to the t dt. So then you would get cotangent u du. So now we just need, what is the integral for cotangent? I forget the, should be ln, ln cosine, I think. Let me double check. No, it's negative. Let me just Google the formula because I don't trust it. Yeah. This will become ln of sine u based on the formula, which is really ln of sine e to the t minus 7 plus c. Does that make sense?
Yes. Cause like you said, it's on that formula sheet, right?
Yeah, it should be in the sheet. I think I wrote them down for you, or maybe I sent you something. I forget. Been 7 days. Ready? No, I'm not doing that guy. Oh, like it's raining hard again. Okay. All right, so that was 5, I think. 6 stuff. Yeah, that's gonna be, there's an X outside and there's a minus. This should be the seeking we did earlier. Do you see how to approach it? It's not as bad as the one we did. This is not too bad.
We just rewrite it. That's what I would do. Dx over x times 9x squared minus 7, close parentheses, negative 1/2. That's what I would do so I can get the u substitution, which is 9x squared minus 7.
If you were to do the u sub, you wouldn't get the du anywhere. It has to be inverse trig approach. So okay, let's go ahead and do it. Integral of dx over x square root 9x squared minus 7. Okay. So you just set up the question. So dx is equal to x square root 3x squared minus square root 7. So you gotta set up the question. Now there is no 3 out here. So what you gotta do is introduce a 3. So 3 dx over 3x square root. You see what I'm saying? Does that make sense? Because you want these
Yes.
to match, right?
Okay, so yeah, because you put the 3 because you want you put the 3 on the x because you wanted to match the x squared. The
Yeah,
u, right?
I need these. I need the u to be the same out here. So that's what the formula has, right? U and u. So I multiply 3 over 3 to make it happen. So pull out the 3, and then you can do your integration. So formula says that will be what? A what is the formula again? One over A, arc seeking U over A. So A is right here. Oh, okay. You know what? I got an idea. Instead of forcing it, well, we just let u equal 3x and du equal 3dx. So now that I have that, the sub will be easy. So you just have du on top. U root u squared minus root 7, which will be 1 over root 7 arc secant of absolute value u over a plus c, which is really, rationalize this guy, you'd get root 7 over 7 arc secant of 3x over root 7 plus c. Yeah, that's it. You can rationalize this guy, but who cares, right? Is there any questions on how we got there?
I'm confused in the very end question why it's the square root of 7 over 7.
Yeah, I mean, I don't have to do that. I can just change it. But the reason is because we don't like square roots on the bottom, so you can fix these two. Right.
Oh, so, it would even the same answer.
Yeah, you would rationalize by multiplying root 7, root 7.
Oh, okay, okay. My bad.
That would change it to having no square roots in the bottom. But technically, this is
Oh,
correct.
okay, okay. So yeah, I just wanted to make sure. Thank you.
Okay. Alrighty. This guy looks like another. I think that's what, arc sine. Yeah. 1 minus x squared. So yeah, that was not too bad. Do you guys want to do this one, or do you see it?
No, we could do another one. That one's more easier.
Okay. What about this guy? This one looks like you can separate the fractions. It doesn't look too bad. But we can do it. Do you see how to approach this? Now you see how you can kind of separate x squared over this and 1 over these two. Which should give you some ln stuff. Is there any questions on this problem? Okay, this guy, that one's super easy. And that one is pretty basic. I think I'll let you do the rest yourself. I think I did the harder ones already. Okay. So on your modules, mine has a lot more crap on it because I'm always messing with it, but you should see this module 1. Like stuff grayed out you won't see because that's extra stuff. So I have more extra video notes and more problems being solved by my friend Jessica. But you also have my notes, and you have the videos we made too. The review is right here, the one that you're going to take just to practice it. And then your actual exam will be here. So you will take this test when you're ready. Make sure you test your lockdown browser. You know, remember at the beginning how you installed it and you tested it out that one time when you took a quiz? So go take that quiz again and make sure your stuff still works. The one that was not third grade. And then come back here and take this. And then you have about 30 minutes to upload it. Upload your work over here.
How many minutes
I gave about 30 minutes.
after the exam?
After you finish the exam and this closes,
Okay,
so when you're done, you have 30 minutes to scan it and put it in here.
got you.
So it should be one file, PDF form, and try to be as clear as you can. Show your steps. Okay.
Yes.
All right, guys. Well.